Hello everyone, this is Ajay Ram Meena. As we saw in the last few slides on the importance of SSM, there are many challenges that need to be handled. The first and foremost challenge is to create and demonstrate health monitoring technology that can be used to maintain structural integrity while also increasing reliability and durability. The next challenge is that a single health monitoring system cannot be appropriate for all applications. It becomes more difficult because it's dependent on a number of factors, like depends on material, depends on components geometry, depends on the damage scenario of a given structural system. The next challenge is to is the is optimization of structural design based on the collected data from health monitoring system. As the result, the information should be fairly accurate and reliable. The next major challenge is damage reduction itself. Damages to the structure as a whole can be identified but cannot be precisely located at the local on each member. That is the most important challenge. The next challenge is to determine the scalability of a damage and its long-term growth and the implication. For that, we need such a system that can determine all these things from the collected data from the sensors. The next challenge is huge data produced by sensors. Though the structure is of large or small scale, the data produced by most of the health monitoring instruments and sensors are huge due to multiple number of locations and continuous monitoring of the structure. This huge data has to process and the most accurate and useful results should be extracted. Data analysis is a still key issue due to computing limits and data processing methodology. The use of big data and artificial intelligence approaches is seen a potential way to address problem of data interpretations. The next challenge is large-scale structures. Large-scale structures like bridges, dams, towers having large scale are most difficult or sometimes impossible to monitor with conventional structural health monitoring techniques. The structural health monitoring process includes many steps. Sometimes it's very difficult to implement all of these precisely. Some of the steps are to mount the sensor at the selected location, acquiring data from the sensor, maintaining and checking a large number of sensor conditions during the complete duration of health monitoring. As another one, as we saw in the previous slide, handling the huge data from its collection to its processing and extracting results from it. The next challenge is site conditions. As the project is of large scale and too many sensors need to be placed, a number of wiring and connections of sensor in a congested place would be large and difficult to handle. There are many factors that come into the picture and make it more difficult. The first factor is the environmental factor. Environmental conditions such as harsh environment, such as speedy wind, heavy rainfall, and drastic change in temperature disturb or damage the sensor. The next challenge is its site condition is accessibility. Access to the desired locations of the structure is challenging in most bridge scenarios since the bridge is built to connect to inaccessible locations. The bottom of the bridge deck is inaccessible in long span suspensions bridge. The next challenge is uncertainty and reliability. Identification must have high reliability over the structure lifetime since unjustified maintenance actions are quite costly to the operator and false warning degrade confidence in the system. Accuracy and reliability may even be more stringent since further optimization of structural design is based on SHM. The source of uncertainty that are involved in this process are related to the type, number, and location of sensor with respect to the location of structural change, the sensitivity of the measured parameters with respect to the intensity of the change, the calibration and tolerance of instruments and sensors and measurements errors, the dependability of the data transmission and storage system. The most fundamental challenge is the fact that damage is a local phenomenon, whereas the SSM system typically detect global damage and thus the damage might go undetected. The final health monitoring result is sometimes inconclusive. The next challenge is cost. It should not exceed the benefits gained so that mass adoptions is slowed down. The constraint of structural safety certification and the existing cost has limited introduction commercial in construction. SHM is still in transmission from a research topic to becoming in the industry norms. SHM delays and disturbs the new construction and it disturbs the smooth service of the structure when the monitoring is taking place during the service life of the structure. There are many more that we need to handle and the next slides will be explained by the another teammates. Thank you.